So today we're doing Chapter 5, Section 6, problem solving using ratios and proportions. And I want to break the notes up into two categories. So my first category, my Roman numeral 1, is going to be when you're changing the ratio or rate. So when changing the ratio or when you're changing the ratio or the rate. So the first type is going to be when you're changing the ratio or the rate. The second type is going to be when you're not, when you're keeping the same ratio. And then the second time you can do a proportion. But here's where you're changing the ratio or rate. For a story problem, I'm going to kind of summarize and maybe go with this. So if you're filming like an action movie, often what they'll do is they'll take like the explosions and they'll film them really close up with a super high-speed camera. And then instead of the explosion lasting half a second or something like that, they take and play it in slow motion, they stretch it out. So it's going to look like a much bigger explosion than what it really is. So in real life it's smaller, it's cheaper to produce, and it's safer for the actors. So what we're going to do is we're going to look at what's the frame rate of the movie when they slow it down. So say you're making a movie, you have this train crash or something like that that lasts 9/10 of a second. And then when they're taking the video, so I'm going to say they have 480 frames per second. So frames over seconds. When you take a movie, basically a movie, or like when you're watching TV, your TV's just flashing up a whole bunch of still images, right? So if you have a flat screen TV, it's probably 120 hertz. So it's flashing up 120 pictures every second. So say you're watching NFL football and Aaron Rodgers throws the football. As they're flashing these pictures, the football is going from like one spot in one picture to a slightly different spot in the next picture, slightly different in the next picture, and so on. But that's what we're talking about with 480 frames per second, saying that the movie camera is taking 480 pictures every second, and then it just plays those back. Okay, so 480 frames per second for 9/10 of a second. For 9/10 seconds. And now say they want to stretch it out to 8 seconds long in slow motion. So if, how do I want to phrase it? If slowed down to last 8 seconds, how many frames per second? How many? Can I do FPS for frames per second? And I'll fix my how. Because if it's too few frames per second, I think like humans, it's around like 16 or 19 frames per second. That's when you can start to see the flicker. So when our TVs do like 120 hertz for most like flat screen TVs, plasma TVs 600 frames per second for a plasma, it's really overkill. It's way faster than your brain can process. But okay, so for this, we're changing the frame rate. That's what I'm trying to get at. That this first one is going to be a certain number of frames per second, and then the second time around it's a different rate. It's a different number of frames per second. Because when we talked about rates were fractions where the units were different, correct? So our fraction the first time our frames per second is 480. Now at the end we're saying, well, what's going to be our new frames per second? It's going to be a different rate. So to do that, if we know how many frames total they take, how many pictures total they take, then we could figure out how many frames per second they show in 8 seconds. So we need to go somewhere from this 480 frames per second to how many pictures, how many frames did they take total. If they filmed for 1 whole second, they didn't, it's a little less than a second there. But if they framed for 1 whole second, how many pictures, how many frames are they going to take? 480. If they did it for 2 seconds, what would you do to 480 to find out total number of pictures? Times 2. So because it'd be 480 frames the first second, another 480 frames the second. So in order to get the total number of frames, you could say the total frames, or just total equals, it's going to be 480 times the time, right? And our time here is going to be 9/10. So if I take and punch that in, we get that it's a total of 432 frames. or there's 432 individual little pictures of this train crash or this explosion. Good? We could probably find one. All right, so now if we have 432 frames, now they're going to take that and make that last 8 seconds. So what do we do with the 8 in our 432 to figure out the frames per second?
So it's divided?
Divide it. And if you're not sure, look at the units. We have right here, we have 432 frames. We want to do frames per second right there. Per means division, right? So in order to get our units to work out right, to get frames per second, we have to take our number of frames and divide it by our number of seconds. So 432 divided by 8, that would give us 54. So it'll be 54 either FPS, or maybe I'll write it out, frames over seconds. So that's kind of how you do it if you're changing the ratio or changing the rate. You figure, oh, what's the total? And then you change it back. So you kind of take it out of a rate, out of a fraction to start out with, and then you put it back into your ratio, your fraction afterwards. Does that seem to make sense? That, I think, is the tougher of the two kinds. Second kind, then, is going to be when keeping the same ratio or rate. So when keeping the same ratio or rate. So this will have to be a different type of story problem. And I was just kind of racking my brain, thought, I captured a couple coons that had a hole underneath my shed, and that kind of turned into this here. So say a raccoon has, what numbers did I come up with? 3 rings on his tail, so 3 tail rings on a 6-inch tail. 6-inch tail. Kind of the brown, black rings. So 3 tail rings on a 6-inch tail. No, I didn't. I caught them, but I didn't count them. So I got 2. No, I let them loose down by the river, down by your house.
Oh, you did?
If the spacing doesn't change, so if spacing stays the same, you could say how many rings on a 14-inch tail. And I'm guessing that some of you immediately are going to jump right to the answer, because you could do it in your head, I'm pretty sure. But if we were to go and kind of do it the old-fashioned way, we want to set up a proportion because it's staying the same ratio, the same number. So we could say, well, if you have 3 rings on a 6-inch tail, so you could do 3 over 6. You could also do 6 over 3 if you wanted to. You just have to make sure that both ratios in your proportion match up. So my 14, do I put that in the numerator or the denominator if I write it this way? Denominator. Because it was a 6-inch tail, our 14-inch tail has to go in the same place. So I'm kind of doing rings in the numerator and length, or inches in the denominator. So our unknown is up on the top. We're trying to figure out how many rings. From there we just go through and we cross multiply and divide. So 6x equals 3 times 14. And then from there 3 times 14 would be 42. So we have our 6x equaling 42. To get x by itself, then we would divide by 6. And we have x, the number of rings, being 7. Does that seem to make sense? So I'll give you a second to copy that, and then I just want to show you one thing. It's not worth copying down, but just kind of wanted to show how something weird happened. Okay, so the same ratio or rate, when you have that, you can use a proportion, you can do the cross multiply and divide. If for this first one, so if I go back to the train, the explosion example, if we were to do that same thing here, and I wouldn't copy this all down, but we said the first one we had like frames per second, and we had number of seconds. So 480 frames per second, they filled a 9/10 of a second thing. If we use this to say, well, now it's an 8-second long video, what's going to be our frames per second? The first time we went through and did this, we came out with that the answer was 54. if we go through this way and do it, we come up with an answer of, now we have 4,267 frames per second. So it doesn't work to set up a proportion if your two fractions aren't equal. So as soon as it says that we're changing the rate, the number of frames per second, that you can't do a proportion.